update. So today we will be practicing some physics MCQs, physics questions, which mainly include the part from mechanics, which include force, velocity, speed, displacement, kinetic energy, potential energy, work, power, etc. type of things. So I created a test yesterday night that contained about 18 MCQs from this part. I practiced them, like I have solved them in the notebooks, that if you find difficulty in these explanations, because in these explanations you don't like yes, by your hand you haven't written anything, you haven't practiced, so you cannot attempt in the paper by just looking at the explanation. So I tried to make sense and tried to make it little easier for you. So the first question is, a marble rolled down a slope at a velocity of 10 meter per second. If the kinetic energy of the marble is 2 joule, what is the mass of the marble? So we are given two things. One is the velocity, that is 10 meter per second, and the other is the kinetic energy, that is 2 joule. So we can use this formula of kinetic energy, that is kinetic energy is equal to 1 over 2 mv square, where m is the mass and v is the velocity. The value of kinetic energy is 2 joules, so we have just put 2 joule here, then is equal to a half mv square, and the velocity is 10 meter per square, so we have just put the value of velocity, that is 10 square. Then it when the 2 came here, it becomes 4 joule, and then is equal to m, and 10 square becomes 100, so 4 divided by 100 is equal to 0.04 kilogram, and when we convert it into gram, it becomes 40 gram, because in the options there was no option of the kilogram, so we have to convert the unit to gram. I hope this is like clear to you. If any difficulty in this, you can ask me on the WhatsApp. Okay, next question was, a tennis ball is thrown and bounced off a wall twice. The displacement of tennis ball is shown by this graph. So this is the displacement time graph. Always remember that we see two things in the graph. Okay, we see two things in the graph. One is the slope and the other is the area under the curve. We find the slope when we need a thing that is like displacement over time, or like whenever we need something that is like del yx divided by del t, or the y axis divided by x axis, we need to calculate its slope, we need to see its slope. And whenever we like see other things, we have to multiply instead of divide, then we see area under the curve. So in this case, as we need to calculate, velocity, we have to find out that which one has the greatest velocity. This is the displacement time graph. We have to divide y-axis by x-axis to find out the velocity. So in this case, we will see its slope. I have very interesting points for this concept, and these are that to calculate velocity from slope, this I told you that divide y-axis by x-axis, so velocity is equal to del d, or the del displacement, divided by del t, that is rate of change of displacement. When graph is not given or the theta value is given, instead of the graph they can also give just theta value. Through the theta value we can also calculate the slope, and these we can calculate by tan theta. Then tan theta will give us the angle at which there is like a graph is made. So I want to share some important points to you. First is, if the slope is like horizontal line, like this one, if the this is the graph, and sorry, it becomes very tilted. If this is like straight horizontal line, let me show you here. This is a straight horizontal line in the slope. This is a slope that is horizontal straight line. The horizontal straight line means that it is zero. Horizontal line slope is equal to 0. So I have told you this thing, that slope of the horizontal line is equal to 0 and the slope of the vertical line is infinite or infinity. So if the slope is like this, then it is infinite. If it is parallel to the y-axis, it is infinite, and if it is parallel to the x-axis, it is 0. It means y-axis is very greater, it is infinite, and x-axis is 0. So when a slope go from horizontal to vertical line, the slope increases. It is a greater value. And when we go from vertical to horizontal line, slope decreases. I am explaining these things here because these will be very helpful to you in the next questions, in the related questions, and also for this question. Let me repeat it for you. For the horizontal line, slope is 0. For a vertical line, slope is infinite. When we go from horizontal to vertical, means when we go from 0 to infinity, slope is increasing, and when we go from vertical to horizontal, slope decreases. And here I have made this infinity parallel vertical line that is showing infinity, and this is the horizontal line that is showing 0. And the other case is when the slope is moving in the opposite direction, like in this direction. We are going from here to here, from starting from here and going like this, then it is negative. So the same things I will explain through this diagram, that is very important. Let's see, this is displacement, this is time. Here we can also like put velocity or time to like when we need to calculate acceleration, because acceleration is the rate of change of velocity. So we can also apply the same things over the acceleration. But for the velocity, let me tell you what happens, that see, this one is the uniform slope. Uniform slope means at every velocity, at every point, the velocity is same. Like the person is covering, or a car or anything is covering the same displacement or the same distance over at a constant time. Like it's changing its displacement, it's increasing its displacement within equal intervals of time. So it is in the constant velocity, or in the constant or in the uniform velocity. Okay, so uniform velocity, whenever graph is inclined but starting from here and going towards right side, then it is uniform graph, uniform slope, or in this case uniform velocity. When the graph is the horizontal straight line, when the slope is the horizontal straight line, then we will say that this is 0. So in this case, if the horizontal line is placed and we need to calculate the velocity, we need to calculate the slope, then its slope will be 0, its velocity will be 0. Like you can see, time is increasing but displacement is not changing. Displacement is same all the time. Time has increased, so it means the car is at rest, the object is at rest. The next is this one. In this slope, it is moving towards x-axis, moving towards x-axis, but it is not in the opposite direction, it is not in the opposite direction. So this is positive but decreasing. This is positive velocity, but it is decreasing. And here you can see in the fourth slope, the velocity is increasing because the slope is moving towards y-axis. So whenever slope is moving towards y-axis, it means velocity is increasing, or if there is here velocity given, then acceleration is increasing. Okay, so this is also positive and increasing. In the fifth case, there is the straight line, straight vertical parallel to the y-axis line. In this case, we will see that the velocity is infinite, it is infinity. And in this sixth slope, it is moving in the opposite direction, so it is negative, but it let me tell you, inclined but straight line means uniform but in opposite direction. It is uniform like this, it is uniform, but it is, as it is in the opposite direction, so we will say that it is negative. Inclined but straight line, uniform but in opposite direction, so velocity is uniform negative. Let me repeat it for you. Like, this is the straight horizontal line, velocity is 0. This is uniform velocity. This is increasing positive, this is decreasing positive velocity as moving towards the x-axis, and this is increasing uh, positive velocity as it is moving towards the y-axis. This is parallel to the y-axis, so it is infinity, and this is in the opposite direction, so it is negative but uniform. And so from this thing we have seen that any slope that is near to the y-axis or that is steeper, that is steepest, is greater, has greater value of slope, has greater value of the velocity in this case. So in this case, if we see, this is the 3, or this is like it is going towards the x-axis, but if we see, it is very near to the y-axis, but like it is moving towards the y-axis, fourth one. So when it will be very closer to the y-axis, we will say like this one, so we will say that it has the greatest value. So our question was that uh, let me show you. Instantaneous velocity formula is rate of change of displacement by time. So this is the formula. If we see this graph here, so the graph was, you can see what is very close to the y-axis. As you can see, this one is very close to the y-axis. This is not so much steeper. This is somewhat close to the x-axis, not very close to the y-axis. So we can say that velocity of A is very great, is the greatest velocity than B, C or D. And if we see for the B and D, these are moving in the opposite direction, so these are the negative velocities, and A and C are the positive velocities. So if we compare A and C, then A has the greater velocity than C, because A is more steeper, it is more like vertical, it is more parallel to the y-axis, and the C is more like going towards the horizontal or the x-axis. So we will not say that C has the greater velocity, A has greater velocity. I hope this makes sense and you have understood it well. If there is any question related to this, you can ask me. Okay, let's move to the next question. So the next question is, we have given the mass that is 1200 kilogram and the speed that is 10 meter per second, and we have to calculate the minimum distance at which an automatic braking system needs to activate to avoid hitting a stationary object. You don't need to be confused by these like things you need to activate or prevent and these things. Like it just first write the data is, we have mass, we have velocity, and we have acceleration. It is saying deceleration. Actually deceleration is the negative acceleration, but you can put it in the acceleration, and you can write -2. As we have given the value of 2, we can write -2. The acceleration is negative acceleration. So let's see. Mass is 1200 kilogram. Initial velocity is 10 meter per second. Final velocity is 0, and acceleration is 2 meter per second. And because after the brakes, velocity becomes 0. Initial velocity was 10 meter per second, and acceleration is 2 meter per square second. Uh, Let me revise you the equations of motion. We have three equations of motion. First one is final velocity is equal to initial velocity plus acceleration into time. And the second one is 2 into acceleration into distance is equal to v final velocity square minus initial velocity square. And the third one is distance is equal to initial velocity into time plus 1 by 2 at square. You have to like cram these equations because they are utilized in a lot of numericals, in a lot of calculations. So from here we can choose which one best suits with our data. So let's see, we have initial velocity, we have final velocity, and we have acceleration, and we need to find out distance. We will apply the second equation of motion, where we can put acceleration as -2 and we will place the distance here, and then final velocity was 0, so 0 square minus 10 square, because initial velocity was 10 meter per second. And we will calculate it like this. If you have any difficulty, you can ask, like, it's simple calculation, but still, if you really find help with this, I can solve it again for you. Let me revise you some things, like equations of motion are applied to objects having constant acceleration or deceleration. Like brakes, here in the question we saw that the braking system, or the braking system can decelerate. The braking system can decelerate the car at 2 meter per square second. This braking system has the constant deceleration power. It has the constant acceleration. So we can apply equations of motion here. Objects moving along the straight line can also be like calculated by applying the equations of motion. And in case of the freely falling objects, like when there is no tension or no pulling force on the falling object, then we can also use equations of motion. And here, in case of the freely falling object, initial velocity is 0, because we are when the ball is thrown from a height, its initial velocity is always 0, and its final velocity becomes greater when it moves towards the ground. So initial velocity is 0 and its final velocity, the formula becomes like this. We will just avoid this initial velocity as it is 0. So our formula will be 2as is equal to vf square, but acceleration is actually the gravity in case of the gravitational acceleration, in case of like the object moving towards the ground due to gravitational force. So we can use 2gh is equal to vf square for the freely falling object. So for this question, as it is not a freely falling object, it is an object having the constant acceleration, having the constant, as car has the constant decelerating braking system. So we can apply the second equation of motion, that is like this. And through calculation we calculated the answer as 25 meter. So our answer is right, it's 25 meter. And we can, if you want, we can also read explanation. It's saying the same thing, uh, but I guess it is a little complicated. Like, if you need any help, you can read it. Of course you should read it, but I think it is a bit complicated. So next question is, researchers collide a 1,000 kilogram car into stationary concrete barrier with a mass of 100,000 kilogram. Which of the following statements best explains why the barrier remains stationary when it is struck by the car? The coefficient of static, like we don't need calculations in this question, but I will like revise you some Newton's laws of motion. I know you like know everything, but still I want, for just the MCAT point of view, I will revise the things for you. Like, Newton's laws of motion are three: first law, second law, and third law. Always remember that first law defines force, second law measures force. So if the question is that which law of the motion defines force, so we will mark it as first law. And which law of the motion, which Newton's law of motion measures force, then it is second law. So in the first law, it is also called the law of inertia, and inertia is actually the measure of mass. So inertia is directly proportional to the mass. If any object has the greater mass, it will be having the greater inertia. If the external force is 0, an object at rest or moving with uniform velocity maintains its state. This is the statement of the first law of motion. First law of motion states that if the external force is 0, is negligible, object at rest or moving with the constant velocity maintains its state. In this question we are saying that there is a 1,000 kilograms car that is then struck into the 10,000 kilogram barrier. Now see, the inertia of the car or the mass of the car is much lesser than the mass of the barrier. So the inertia of barrier is much greater, so it will not change its motion, it will not change its state, it will not change its state of rest, so the barrier will remain stationary. So it is actually explaining, or it is actually explaining the inner first law of motion, that is the inertia of the barrier is much greater than the inertia of the car. Okay, I just want to revise the other laws for you as well, so that if any question came related to the second law or third law, you know it. So second law, Meyer's force, it states that if the force is provided, object will accelerate, and force is always directly proportional to acceleration, and force is also directly proportional to mass. So F is directly proportional to ma. We can write the constant as k, and constant value is 1, so F is equal to ma, and we can calculate the acceleration by the formula a is equal to F over m. And then there comes the third law. In the third law, it states that every action has equal but opposite reaction, and in the third law, we say that forces exist in pair. There are action and reaction forces, and these two forces are always acting on the two different bodies. Like, you cannot say that this is following the third law of motion if the two forces are acting on the same body. For example, if there is a ball and there is the force of gravity from below, and if there is any tension from above, this is the same object, so this is not actually following the third law of motion. When we will be having the two objects, like there is the ball and there is a car, then we can say that actually now, like, it has provided a force, and as it doesn't mean that the ball will also like strike with the car and this is the reaction. If only like ball has become deformed, or the ball shape has been changed, this is also a type of reaction. So our teacher said this, that it's not like there should be a reaction from the other object as well. Only if its structure is distorted, or something bad has happened to it as well, then it is also a reaction. Like car also gets some deformity from the striking the ball, so this is, or by striking anything like tree, etc., so this is also a reaction force. But always keep in mind that action and reaction forces act on two different bodies. If there is like two forces acting on the same object, then these are not third law, these are not following the third law of motion. Okay, next we are saying that resultant of action and reaction forces can't be predicted. So if there comes an MCQ, there comes a question where they say that whether we can calculate the resultant of action and reaction forces, then you will say that no, it can't be predicted. This will be the right option. There comes a question in our exam like this. So question 5 we will do later, because it is like entirely different one. Let me see what was that. mm, it is about friction. I want that I teach you the topic first, because if you know it's better, you can also solve that. But if you haven't studied that, then I can take a class or the 10 to 15 minutes on explaining this topic, and then we can solve it. The next question was, I'm so sorry, I was marked this answer before solving it, and I wanted to see the explanation, and that's why I marked it. I'm so sorry. What is the distance traveled by the vehicle as it accelerates from 0 meter per second to 10 meter per second? So here it is. Let me see. Here is the graph they have given us, that this is the speed and this is the time, and we have to actually see that what is the displacement, what is the distance traveled by the vehicle as it accelerates from 0 to 10 meter per second. So here it comes the 10 meter per second, and this is the 4 second. So we will As I already told you that there are two things that we see in the graph. One is the slope. We calculate the slope when we need to divide the y-axis by x-axis. Like when we have to calculate the acceleration speed over time, we will calculate it through the slope. But when we have to multiply the things, like we know the formula of speed or velocity is speed is equal to distance divided by time. So in this case we need to calculate distance. So distance is equal to speed into time. Distance is equal to speed into time. So in case when we have to multiply two things, we have to multiply the values on the y-axis by the values on the x-axis, then we will use area under the curve. So area under the curve, there are two types. There are area for the triangle. In case of triangle, we will use the formula 1/2 base into height, and in case of rectangle we will use base, just base into height. It is not half, it's like base into height. And in case of the because it is triangle, in our question it is triangle, and so we will use this formula. It will be 1/2 base is 4 seconds, because when the car reaches 10 meter per second velocity, its time is 4 seconds. At the 4 seconds it has the velocity of 10 meter per second. So we will put the values of base, that is 4 second, and a height, that is 10 meter per second, and we will calculate the distance through this. So it is very simple. You can see this was 20 meter. 20 meter is the right answer. Again, if you haven't understand it, you can approach me. You can just text me on WhatsApp, and I will reply to that text. Next question is: a seat belt holds a 70 kg crash test dummy in the car seat during a collision that slows from 90 km per hour to 0 km per hour. So it means that the initial velocity of the car is 90 km per hour, and it comes to the 0 km per hour as the final velocity. So, and they are asking about the magnitude of the work done on the crash test dummy. Sorry. Okay, in this case we are given mass, that is 70 kg, initial velocity was 90 km per hour. We can convert these units into meter per second, as kilometer is equal to 1000 meters. So we will just multiply 90 by 1000, and per hour, it means it is divisible, it is under like divide. So we will divide it by 3600, because 1 hour has 60 minutes, and 60 minutes have 60 seconds. So whenever there is 1 hour and we need to convert 1 hour into second, then there are 3600 seconds in the 1 hour. So we will just write 3600 for the hour, and we calculate it in the meter per second. So it will be 25 meter per second, and its final velocity was 0 km per hour. Here we will apply the formula of work, that is work is equal to change in kinetic energy, or the kinetic energy. Okay, let me tell you one thing, that the work, the kinetic energy, and the potential energy, sometimes these formulas for these three become similar. They We can like apply the formula for the work, we can apply the formula for the kinetic energy or the potential energy according to the question, even though they have asked about the work, but still we can use the formula for the kinetic energy, because it's like similar. You can use whenever you find that the data is not according to the work of like F into D, it is according to the mv square. So data of mass, put that in the m, and v square, that was velocity in meter per second, you can like put this value, and our answer was 21875 uh, joule, and we can just so correct it as 20,000. You have to mark the most related or the most near answer. So the most near value here is 20,000 joule from 21,000. we just needed to calculate it like this. Next question is question number 8, and it is a very simple question. It is they have given us the data, this graph, and this graph has a dotted line slope. You can see that this is a dotted line slope is for which graph? Speed time graph. So speed time graph represents us the acceleration, and this is moving in like opposite direction, so this is the negative acceleration. But what are the options? We have acceleration, we have displacement, we have kinetic energy, and we have work done. So this is the slope of the speed time graph, so it is acceleration. Mm, so it's acceleration will be the right option. I hope it made sense. Still you can ask if you haven't understand it. Next question is question number 9, that is about the mass spring system. It says that there is a 1 meter spring that is compressed to its half of its original length, means it has the 1 meter as its initial length, and now it is half to its original length, means 0.5. Its final length becomes 0.5, and they are asking that what is the potential energy stored within the spring. So dear, it's like a very versatile topic in math spring system, so I think you should also like learn this from the lecture. You can like take a lecture from me, because I found my notes and I revised them now. So you can like whatever is easy for you, you can like learn from YouTube or whatever. So I have written this formula here. So for the formula, in case of potential energy, in case of the mass spring system, we see that it is 1 over 2 kx square. Kx square, or you can like see that it means the here x means x naught means x that was like final or the changed length, and x square means that is original length. So we will put here uh, the values. 1 over 2 40 was our constant value. It is a constant, it has to be given in our exam, so don't worry about this value, this will be given. Okay, 1 over 2 40, then we will put the value of its original length, that was 1 square, and its final length, that is 0.5 square. I'm so sorry, I just told you little opposite. This one is the original length, as it is O is representing original length, and this one is changed length, or this one is actually the length that has been halved from the original length, so it means it is 0.5. So we will just calculate this, and our value will be 5 joule. So the potential energy that is stored in the spring is 5 joule. Our next question is a force of 50 Newton is used to push a wheelchair forward at constant velocity. So the velocity is constant, and if the wheelchair is displaced 0.5 meter each second, what is the mechanical power expended when transporting the wheelchair? So they are asking about the power. The formula of power, let me show you. There are a lot of formulas for the power. These are the values given in our data. So we can use these formulas for the power. One is power is equal to work divided by time, or the rate of change of work is equal to power. The second is the power is equal to kinetic energy divided by time, and third one is power is equal to potential energy divided by time, or mgh divided by time, because potential energy is also mgh. And the 1 2 3 4 5, and the fifth one is power is equal to F dot V. Because power is a scalar quantity, and in case of the scalar quantity we use the dot product. In dot product we just need to multiply the things. So in this case and one other thing is that in the dot product we can also use the cos theta, and in case of the cross product we use the sin theta. We can also write it as power is equal to F V cos theta. but as we don't have the angle given here, we have just given the normal values, which are force is equal to 50 and velocity is equal to 0.5 meter per second. So this is very easiest one for us. We can use this formula of force into velocity. Force was 50 newton and velocity was 0.5, so our answer will be 25 watts. So 25 watts is the correct answer. Coming to the next question, there is a very large statement given here. If you want to like give it a read, you can give it a read, but must read this last thing. One, this the distance etc and the values thing, and you don't like if you don't have a time in the exam, you don't need to waste your time over reading again and again these very large statements, because mainly, so the statement given at the last, at the end, is very important, like these three lines in which they are asking a question that there are two astronauts that use their jetpacks to position a solar panel attached to a large space station, as shown above. So don't be worried about this. They have just given us a pivot point and there is a solar panel, and this is the force applying to it, and this is the distance. So what they are asking is about the solar panel is at rest relative to the space station and not rotating. One astronaut applies 100 Newton force of 100 Newton of force 30 meter from the pivot point towards the right. What is the force applied towards the left by the second astronaut, and how far from the pivot point is it applied to prevent the solar panel from rotating? So they are saying that there is one astronaut that is applying 100 Newton force, and that is 30 meter away from the pivot point towards the right. And what level of other force should the second astronaut apply, so that our solar panel should not rotate, so that the solar panel do not rotate? We have to prevent the solar panel from rotating, so the force that is provided by the second astronaut should be that much that prevent it. So how we will find out this? So actually this is like we have to find out the torque formula in this case. So torque is equal to F into D, and D is the distance from the pivot where the force F is applied. One astronaut applies a force of 100 Newton at 30 meter for pivot point, so he produces torque of 3000 Newton meter. He produces a torque of 3000 Newton meter, and for preventing the rotation, other astronaut will have to produce the same torque in the opposite direction. So there should be like 3000 Newton meter of the force of the torque that should be um, provided by the second astronaut. But they were not asking about the torque, they are asking about the force. So for calculating force, we just need to like write this one as torque is equal to force into displacement, and this is like 3000, and they have given us already the force 1000 Newton meter. But we don't need to like write that. We need to find out that value that suits like 150 into, or if you want derivation I can also do that for you, 150 into 20. So which answer is with our just see, 100 into 10 is 1000, so this is not our option. 100 into 20 is 2000, this is not also our option. 150 into 10 is 1500, this is not our answer. And 150 into 20 is our answer, because 150 into 20 is equal to 3000, and we have to provide the same force by the second astronaut that was provided by the first astronaut, because this is the thing that we need to prevent our solar panel from rotating. I hope it made sense, and if it's not clear you can ask, don't hesitate. The question number 12 is, an astronaut on Mars uses a short burst from a rocket engine to launch an atmosphere sampler vertically upwards to different heights. If the speed of the rocket at the end of the engine burst were doubled, then the maximum height of the rocket would. Okay, see, this is like a tricky question, but this is very interesting and this is very easy, but you need to practice it. We projectile system, we can have also the class at the projectile system, because this is also a lot of things, a lot of formulas for you. But for this time we have asked about the height, and as you want just to practice the question, so I just write the formula for the height. So let me show you this one. I'm so sorry. So the formula for the height of a projectile is that height is directly proportional to initial velocity square, and height is directly proportional to sine square theta. It means the formula is this one: vi square sine square theta divided by 2g, or we can just write it as height is equal to v square sine theta square divided by 2g. Okay, this one is the formula for height. You have to cram this formula. This is very important. But in this case, because maximum velocity at the projectiles is at maximum velocity at 90 degree, and we you can use see here we have given this as maximum height of the rocket. So at maximum height is at 90 degree, projectile is at maximum height at 90 degree, so we will use 90 in the theta in the angle place, and we will use this formula: sine 90 is equal to 0, so we can just write v square over 2g. And as in the question they said that if we double the velocity, so we will double the velocity, we will write 2v square divided by 2g, and that will become we just need to, this becomes 4, just see, this becomes 4 v square divided by 2g. So can't we just write this as 4 v square over 2g, and this becomes this formula. So height is 4 times the maximum height, or the it is increased by a factor of 4. It is 4 height, it is 4 into height, means it has been increased by the factor of 4. So we can mark this option, we can mark the option A, that is increased by a factor of 4. Again I can repeat it. This was the height formula: height is equal to vi squared sine square theta divided by 2g. But in case of this, maximum height of the projectile is at 90 degrees, so we can put 90 here and it becomes 1. Then we calculated it by doubling the velocity, and it becomes increased by 4 by the a factor of 4. But still I had some shortcut for this, where you don't need to confuse in this. I will send that in WhatsApp. On WhatsApp I will send the note. The next question is: at its top speed, a Mars rover generates a constant force of 400 Newton and uses 100 watt of the battery power. What is the top speed of the rover? It is just like our power formula, that was F dot V. So we will use the same formula here: F into V, that is power is equal to F into V, and we will just put the values. Power was 100 watt and force is 400 watt. So we will use 100 over 400 is equal to velocity, that is 0.25 meter per second. uh, you just don't need to read all this statement, as I already told you, and this statement is the same as the previous 4 questions. So this is like a series of questions with the same kind of statement. So you don't need to read it again and again. It's like just read the question that is asked, and if there is something that is not in the question, then you can go to the statement and go through that. Okay. Next question is question number 14. They are saying that a researcher built a telescope with a magnification of 100 to view Mars from Earth using lenses with magnification of either 10 or 25. To achieve the desired magnification, which of the following lenses are combined? So just see it. This is also very interesting. He builds a telescope with magnification of 100. It means it's his desired magnification is 100. He want to make a telescope with the 100 magnification, and there are the two lenses. In case of the telescope, he want to use the like two lenses. As for like making this, he is saying that for the magnification of 100, which lenses he should use, either 10 or 15. So we are saying that which lenses should be combined: two lenses with magnification of 10, two lenses with magnification of 25, four lenses with magnification of 25, or two lenses with magnification of 10 and 25. Dear, what is like this: the total magnification of telescope is equal to product of two lenses. So total magnification here was 100, and 100 should be equal to the product of two lenses. If we see in these questions, then if we see this is the 10 into 10, so this should be the correct option, because two lenses of 10 into 10 is equal to the desired magnification 100. But if we use the magnification of 25 into 25, it is not 100. Again, if four lenses with the 25, it is not again 100. And if we use two lenses with magnification of 10 and 25, it is also 250 and not 100. So we have to use the first one, that is the two lenses with magnification of 10. The next question is, what is the ratio of the shortest to farthest distance from Earth and Mars as these planets orbit the Sun? Here you have to learn these values. These values are actually, the closest distance is 50 million kilometer or 54 something million kilometers, and the longest distance is 401 million kilometer. So what is like that, you maybe in some book, in our book, these are the values as 54.6 as the closest distance, and longest distance is 401 million kilometer. And still, if we see the distance from the Earth to the Mars, from the statement that was given in the question, they were saying that from the Sun to the Earth there is distance of 150 million kilometer, and from the Sun to the Mars there is a distance of 200 million kilometers. So we can just derive the value from here also, which means that the distance from the uh, Earth to the Mars will be 50 million kilometers. So the small closest distance will be 50 or the 54 million kilometer, and longest distance is 401 million kilometer. We will have to give the ratio, we have to calculate the ratio, that will be the closest ratio longest. We just need to like divide, and 54 divided by 401, and we will get this value. So 1 ratio 7 is the nearest option. So we can mark this as 1 ratio 7, and this is the correct option. Next one is this one: an astronaut pulls a car of rock sample the distance of 60 meter along flat ground using a teeter attached to there, and there is given the tension and the angle, that is 30 degree relative to the horizontal, and they are saying what is the approximate work that the astronaut does on the car. So we have given the data as distance, that is 60 meter, tension that is 40 newton, and angle is 30 degree relative to the horizontal. So dear, what happens that when the angle is relative to the x-axis we use cos theta, and when the angle is relative to the y-axis it's the sin theta. Or we use this, we can like say that scalar quantities follow the dot product, and dot product is derived as cos theta, and work is a scalar quantity, so we can use work is equal to ft cos theta, and we will just put the values 40 into 60 and then cos 30. Cos 30 can also be written as like under root 3 over 2, and also as either like cos 30 is equal to under root 3 by 2, if in case there is you know the value of under root 3. But if you don't know, you can just remember it as cos 30 is equal to 0.86. You must have to uh, like cram these values of I have written them in my notebook. I will also send them to you. cos 30, cos 60, cos 45, cos 90. Same like for the sine, you have to know this value of sine 0, sine 45, sine 30, sine 60, sine 90. So you need to like remember these values by your heart. Okay, I will share the file with you where there will be the written values, because mostly in exam they will give the angle of 30 degree or 90 degree or 60 degree or 45 degree or 0 degree, uh, not like other thing than this. So mostly these values can be used. Here we just put the 0.86, and 40 into 60 was 2400, and the answer for our work is equal to 2064, that is approximate to 2000. So we just marked it as 2000 joule. Our next question is, what is the maximum possible height of a 0.15 kilogram base ball if it has 90 joule of kinetic energy after being hit by the baseball basket, baseball bat, sorry. So mass is given, that is 0.15 kg, kinetic energy is 90 joule, and maximum height we need to calculate. In the ideal case, we say that loss of when like they are saying about the baseball, it's just assume this is a ball and it is falling towards the ground, and when it is falling towards the ground, it is losing its potential energy, that is mgh. It is losing its potential energy, and it is gaining its kinetic energy. So in the ideal case, we can say that when there is no tension on the ball, on the object, we say it's the ideal case. And what happens in the ideal case, that loss of potential energy is equal to gain in kinetic energy. So we can write it as the kinetic energy formula, that is mgh, and that is equal to 1 over 2 mv square. So mgh is equal to kinetic energy, and we can calculate the height from this as height is equal to 90 divided by 0.15 into 10, that was mass, and 10 is our gravitational acceleration. So we just wrote this, and this came out to be 60 meter. One other thing, if there is no calculator allowed in your exam, then you also need to like know how you will deal with these decimal or the point values. Like I if give you an example, this was 1.5, I don't have a calculator and I don't know what will be my answer. Simply I will do that 1.5 is the half of 3, so I can write it as 3 by 2. It is the half of 3, and what happens, I will take this value that is under the divide as 90 into 2 and divided by 3. 90 into 2 is 180, and I can like uh, it, solve it as 3 is 3 6 is equal to 18, and it will be 60. So I can calculate it as this by hand if I don't have a calculator in the exam. So our last question is, I hope you have understood this. Our last question is, performing a medical examination assessing the conduction of nerves, a physician sends an electric impulse down the forearm of a patient. What is the average velocity of the electric signal if it arrives at an electrode 25 cm away from its initial position following 5 meter second of the travel? Okay, let's see this. So it is also very simple. We don't need to like see the current, electricity in this. Simply dealing with the mechanics. They have just given us the tricky question. In this case, this is a mechanic question, not the electric question. So let's see, velocity is equal to rate of change of distance. So the initial distance was sorry, yeah, the final distance was 25 centimeter and the initial distance was 0 centimeter. We can deal with these units to convert them into meter by simply multiplying by 10 raised to power minus 2, or the exponent value, that is centimeter is 10 raised to power minus 2, as you, I guess you have, you know this 10 into minus 2, and millimeter is equal to 10 raised to power minus 3. And they said that time was given in the millisecond, so we can like multiply it by the exponent minus 3, and there will be the answer, that is 25 divided by 0 0.5. We can deal with this 0 0.5 by 25 divided by 1 over 2, and this 1 will come over here, this 2 will come over here. 25 into 2 and 1 is like negligible, and we will write it as 50 meter second. So our answer will be the 50 meter per second. So I hope you have understood it as well, and I'm so sorry if I like made the incorrect marks on your exam. You just need to practice it, and if like there is you can like practice it again from creating a new test. So this was all from my side for today. I hope you have understood well, and if you know anything about physics other than like where you find difficulty in other subjects, in other topics like electricity, current, electricity, or um, I guess there are a lot of things like friction, or like simple projectile motion. It has a lot of formulas, a lot of concepts that I can help you with. Then you can tell me. Okay. Thank you so much. Bye.